Good morning, dear students. My name is Ferhan Mazher, and today is 10th of February 2022. Right now, I am with the ninth Cambridge class, and the subject we are studying is D Maths 4024. We are working on the syllabus, and we are studying the book D3. The name of the book is New Syllabus Mathematics 7th edition, and we have started studying the chapter number 12 of this book. The chapter is about the area and the volume of the similar figures and the solids. So today we are going to start the exercise 12A, and today's session we are going to attempt question number 1 to question number 10, and we will solve the rest of the exercise in another video. So I will hope that you will enjoy this video. So the exercise 12A showing up on your screen, and here we have find the unknown areas of each of the following pairs of the similar figures. So the question number 1 is showing up on your screen. So this is exercise 12A, question number 1A part. Here the two triangles are shown, and you can see clearly that the two angles are same. Two corresponding angles are same in both these triangles. One is smaller triangle, the one is big triangle. Both these triangles, they are similar to each other. And remember one fact, that if the two figures, they are similar to each other, then the ratio of their areas is equals to the square of the ratio of their sides. So here the sides are given and their angle, one of the angle is given, one of the areas is given, and we want to find out the area of the second figure. So A1 by A2 will be equals to L1 by L2 whole square. And from there, I will be able to crack this question. So let's start this question, and I hope that you will be able to understand. So the question number 1, A part is area 1 by area 2 is equals to L1 by L2 and the whole square. Area 1 is given. The area 1 is 64 centimeter square, and the area 2 is question. The side 1 is 8 centimeter and the side 2 is 2 centimeter. So I will write 64 by A2 equals to 8 by 2 whole square. 2 and 8 will be cancelled. That will be 4. 4 square will be 16. So you will have, if I will make A2 the subject of the formula, you see what will happen. A2 will be equals to 64 divided by 16, and that will be 4 centimeters square. So this is how you will find the area 2. Okay, so now the question number 1 and its B part. These are the two figures given. They are similar to each other, and the area 1 of the figure 1 we have to find out, and its side is given, that's 0.4 meter. That's the base of that figure. Now area 2 is given, that's 0.6 meter square, and the side is 0.2 meter. Because both the figures are similar to each other, so the ratio of their areas will be equals to the square of the ratio of their sides. So I will apply the formula. Let me show you. Here we go. So area 1 by area 2 is equal to L1 by L2 whole square. Area 1 is question. Area 2 is 0.6. The L1 is 0.4. L2 is 0.2. And we will have whole square on it. So 0.4 divided by 0.2, and that will be 2, and its square will be 4. So this 0.6 will come to this side. It will multiply with the 4. You got the area 1 equals to 4 times 0.6, and that will be 2.4 meter square. So that was the B part. Okay. So now the C part. Area 1 is 125 centimeters square. The length is 15 centimeter. Area 2 is question, and the length is 6 centimeter. So because they are similar, so that can be written as area 1 by area 2 will be equals to the L1 by L2 whole square. Area 1 is 125, area 2 is question, length 1 is 15, length 2 is 6 and whole square. So 125 divided by A2 equals to 25 by 4. If you divide 15 by 6 and you take square of it, you get 25 by 4. So make A2 the subject. A2 will be equals to 125 multiplied 4 divided by 25, and that will be equals to 20 centimeter square. So that's question 1C part. Okay, so we will move to the next question. The next question is question number 1. It's D part. The two figures are given. They are similar to each other. And area 1 is question. The side is 12 centimeter. Area 2 is 48 centimeter square. And its side is 8 centimeter. And we know the formula. Area 1 by area 2 will be equals to the length 1 by length 2 whole square. So here we go. Area 1 by area 2 equals to L1 by L2 whole square. Area 1 is question. The area 2 is 48. L1 is 12. L2 is 8. So we will take whole square on it. So area 1 by 48 equals to 9 by 4. When you divide 12 with 8 and you take whole square of it, you get 9 by 4. So area 1 will be equals to 48 multiplied 9 divided by 4. And that will be 108 centimeter square. I hope you understand. And here we go. We are done with this part. Okay, so question number 1 is completed. Okay, so let's go to the question number 2. So no, sorry, we have question number 1 and it's E part. So here we have two similar diagrams. And the area 1 is 12 meters square. The arc 1 is 4 meter. Area 2 is question, and the arc 2 is 6 centimeter. Remember one thing: the length, the width, depth, height, perimeter, circumference, arc length, they all are like length. So I will apply the formula area 1 by area 2 equals to L1 by L2, or here in this case, arc 1 by arc 2 whole square. So that's the E part. And question number 1, E part, area 1 by area 2 equals to the length 1 by length 2 whole square. 12 divided by A2 equals to 4 by 6 and whole square. So when you take 4 by 6 whole square, you get 4 by 9. So 12 by A2 equals to 4 by 9. A2 will be equals to 12 multiplied 9 divided by 4, and you get 27 meters square. Okay, so let's move to the next part. The next part is question number 1, and it's F part. These two triangles are similar to each other, and the area 1 is 24 centimeters square. The base is 6P, and the second figure, area 2, is the question. The base is 3P centimeter. So we have to find out the area 2. Because they are similar, so the ratio of their areas A1 by A2 will be equals to L1 by L2 whole square. So let me show you. Question number 1, and it's F part. Area 1 by area 2 will be equals to the L1 by L2 whole square. 24 by A2 equals to bracket 6P divided by 3P bracket close whole square. P and P will be cancelled. 3 and 6 will be cancelled. You get 2 square will be 4. So you have 24 divided by A2 equals to 4 by 1. So area 2 will be equals to 24 divided by 4, and that will be 6 centimeter square. 6 centimeter square. So I hope that you understood the question number 1. Very easy question, and just it gave you the practice on one formula. A1 by A2 equals to L1 by L2 whole square. Okay, so now we have question number 2. He says find the ratio of the areas of the two circles whose radii are 4 centimeter and 7 centimeter. So area 1 by area 2 will be equals to the radius 1 by radius 2 whole square. So whatever the ratio you will get, same will be the ratio of their areas. So let me show you. So the area 1 by area 2 will be equals to the radius 1 by radius 2 whole square. Area 1 by area 2 will be equals to 4 by 7 whole square. So area 1 by area 2 will be equals to 16 by 49. So area 1 ratio area 2 will be 16 ratio 49. So that is how you do question number 2. Let's move to the next part, and here we go. A triangular plot of the land PQR is such that the PT is 6 meter and the PR is 10 meter. ST and the QR are two water pipes that are parallel to each other. The area of the triangle PST is 24 meter square. So the area of this small triangle PST is given, that's 24 meters square. The first question is find the area of the land occupied by the triangle PQR. We try to find out the area of that big triangle. And then they say find the area of that SQRT, that trapezium there. So the strategy is very simple because the PQR, the big triangle, and the PST, the small triangle, they are similar to each other. If you want to prove that they are similar to each other, the methodology is very simple. You see, this angle here and this angle here is same. This angle here and this angle is same because they are corresponding angles. And this angle will be the common angle between the small triangle and the big triangle. So both the small triangle and the full triangle, they are the big triangle, they are similar to each other. Small triangle means the triangle PST, and the big triangle or the large triangle means the triangle PQR. Okay, so we have to find, because these two triangles are similar to each other, this side of the small triangle is 6 meter and this side of the large triangle is 10 meter. So the area 1 by area 2, you can apply that formula. Okay, so here we go. So the area of the PQR divided by the triangle PST, that will be the PR by PT whole square. So the triangle PQR divided by 24, that PST small triangle, its area is 24. It will be equals to the bracket 10 divided by 6 bracket close whole square. So the triangle PQR will be equals to 24 multiply 100 divided by 36, and that will be 66 whole 2 by 3 meter square. 66 2 whole by 3 meter square. So that is question number. That is the first part of the question number 3. In the second part of the question number 3, they want you to find out the area of that trapezium SQRT. So the method is very simple. From the big triangle, subtract the small triangle's area. You will get the area for that trapezium. So the area of the big triangle is 66 whole 2 by 3 minus the area of the small triangle is 24. So you will left with the 42 whole 2 by 3 meters square area. So this is how you will do the question number 3. Hopefully you understand. Now we have the question number 4 on your screen. He says, find the unknown values in each of the following pairs of the similar triangles. It's already mentioned in the question that these triangles, they are similar to each other. So in the A part, the area 1 is 24 centimeters square. The length 1 is 8 centimeter. In the figure, and the second figure, the area 2 is 6 centimeters square, and the length 2 is 3 centimeters. So I want to find out the length 1. So I will apply the same formula. Area 1 by area 2 equals to length 1 by length 2 whole square. So here we go. So area 1 by area 2 equals to length 1 by length 2 whole square. That will be 24 divided by 6. That's the ratio of the areas. Equals to A by 3 whole square. So 24 divided by 6 is equals to A square divided by 9. So you can cancel 6 and 24. That will be 4. So the A square will be equals to 4 multiply 9, and that will be 36. So we will take square root on both the sides. So the A will be equals to 6 centimeter. So the area, so the length 1 will be 6 centimeter. Length 1 will be 6 centimeter. That's how you do question number 6, A part. Let's go to the next part, and the next part is question number 4, B part. Here the area 1 is 10 centimeter square, length 1 is 5 centimeter, area 2 is 90 centimeter square, and the length 2 is question. So I will apply the same formula. Area 1 by area 2 is equal to length 1 by length 2 whole square. So that's the B part. Area 1 by area 2. Area 1 by area 2 is equal to length 1 by length 2 whole square. So 10 by 90 equals to 5 by B whole square. And 1 by 9 equals to 25 by B square. So B square will be equals to 9 multiplied 25. So take square root on both the sides. So you got 3. B is equal to 3 multiplied 5, and that will be 15 centimeter. So the question number 4, B part, hopefully you understand. Question number 4 and its C part. Area 1 is 15 meters square, length 1 is 5 meter. Area 2 is 240 meters square, and the length 2 is C centimeter. C meter, sorry, I said centimeter, C meter. So I can find out the area, that length very easily. So the area 1 by area 2 equals to L1 by L2 whole square. 15 divided by 240 equals to 5 by C whole square. So 15 by 240 equals to 25 divided by C square. So C square will be equals to 25 multiplied 240 divided by 15. So C square will be equals to 400, and I will take square root on both the sides. So C will be equals to 20 meter. C will be equals to 20 meter. So that's question number 4 and C part. Question number 4 and its D part. Here the area 1 is 27 centimeter square. The length 1 is 6 centimeter. Area 2 is 12 centimeter square, and the length 2 is D. So I can apply the formula because they are similar to each other. I can apply the formula that the area 1 by area 2 is equals to the length 1 by length 2 whole square. So the area 1 by area 2 is equals to the length 1 by length 2 whole square. So area 1 is 27, area 2 is 12 equals to 6 by D whole square. So you will have 27 divided by 12 equals to 36 divided by D square. So D square will be equals to 36 multiplied 12 divided by 27. So you get D square equals to 16. So take square root on both the sides. So D will be equals to 4 centimeters. So that is how you do question number 4 and its D part. So this is how you will do the question number 4 and its D part. You can see area 1 by area 2 equals to L1 by L2 whole square. 27 area 1 and divided by the 12 area 2 is equals to L1 is 6. L2 is D, so 6 by D whole square. So 27 by 12 equals to 36 by D square. So D square is equals to 36 multiplied by 12 divided by 27, and D square will be equals to D square will be equals to 16, and take square root on both the sides. So D will be equals to 4 centimeter. Okay, so here we go. Question number 5. The perimeters of two similar regular hexagons are 10 meter and 8 meter. Given that the area of the larger hexagon is 200 meters square, find the area of the smaller hexagon. I told you in the start of this lesson and that in this chapter we deal the length, the width, the height, the breadth, the depth, the perimeter, the circumference, the arc length. They all are like a length. They all are, we deal them like a length. So for example, in this question, it said perimeter. So the perimeters are like length, okay? So the area 1 which is 200 meters square. That's the larger one. And the length one is 10 meter. The length 2 is 8 meter, and the area 2 is the question. So these are basically the parameters. So they are like length. So I will apply the formula that the area 1 by area 2 is equals to the perimeter 1 by perimeter 2 whole square. So here we go. So the area 1 by area 2 equals to perimeter 1 by perimeter 2 whole square. So 200 divided by A2 equals to 10 by 8 whole square. So 200 by A2 will be equals to, when you on your calculator, you will do 10 by 8 whole square. You get 25 by 16. So the area 2 will be equals to 16 multiplied 200 divided by 25. And the area 2 will be 128 meter square. So this is how you do question number 5. And let's go. Let's go to the question number 6. So here we go. In the figure, CAE triangle is an enlargement of the triangle CBD. So here we have the triangle CBD, and the CAB is its enlargement. He says with a scale factor of 4 by 3. It means 4 by 3 means image divided by object. The scale factor is image divided by object, the length of the image by the length of the object. So it means that the CA is 4, and from C to B it is 3. That's the ratio of those sides. So this is 3, this is 1, the total thing is 4. This is 3, this is 4, this is 3, this is 1, so the total thing is 4. Given that the area of the triangle CBD, the small triangle, its area is 9 centimeters square, find the area of that trapezium ABDE. Okay, so very easy. I will find, first of all, the area of the big triangle. From the big triangle's area, I will subtract this small triangle, and I will get the area of that quadrilateral. It looks like a trapezium. Okay, so let me show you my solution. Okay, so here I have written the ratios on these sides: 3, 1, and total is 4. 3 and 1, and total is 4. 3 small triangle, that's 3. The big triangle, that's 4. So the sorry. Okay. So the area of the CBD triangle by the CAE triangle will be equals to the CB divided by CA whole square, because they both the triangles are similar. So 9, the area of the CBD is 9, and divided by the area of the CAE equals to 3 by 4 whole square. So you get 9 by 16. And when you cross multiply it, so that the area of the triangle ACAE will be equals to 9 multiplied 16 divided by 9. So the answer will be 16 centimeter. So centimeter square, I mean. So now you know the area of the CAE, that full triangle. You know the area of that thing. If you want to find out the area of this quadrilateral from the big triangle, subtract the small triangle. So area of the ABDE will be equals to the triangle CAE minus the triangle CBD, and that will be 16 minus 9, and that will be 7 centimeters square. So this is how you will do your question number 6. Okay, so let's move to the next question. The next question coming up on your screen is question number 7. In a scale drawing of a house, the width 150 centimeter of a door is represented by a line 30 millimeter long. So a door was 150 centimeter long in actual house, and on the map it is represented with the line of 30 millimeter, and that will be 3 centimeter. So 150 centimeter actual length on the map is represented with the line of 3 centimeter. Find the actual land area in square meters occupied by the house if the corresponding areas on the plan is 3250 centimeters square. So that's question number 7. So you can use that formula, area 1 by area 2 is equals to the length 1 by length 2 whole square. I have used a little different methodology. So here you can see that the map is the actual map, the length in lengthwise, the map and actual 30 millimeter means 150 centimeter. So it means 3 centimeter means 150 centimeter. So the scale for the area will be the length scale, you square its both sides, then it becomes the scale for the area. So 3 centimeter means 150 centimeter length in actual. So if you want to write it in the for the area, so it will be 3 centimeters square and original will be 150 centimeters square. So the actual area on the map is 3250 centimeters square, and we want to find out what is the actual area. So 9 by 3250 equals to 22500 divided by x. So x will be equals to 22500 multiplied by 3250 divided by 9. So that will be 812500 centimeters square. So I will divide it with 10,000 to convert the centimeter square into meter square. So 812500 divided by 10,000, and you get 812.5 meters square. So 812.5 centimeter, meter square. So that is question number 7. So the actual area will be 812.5 meter square. That was the question number 7. Question number 8, in the figure HG is parallel to the QR. You see this HG is parallel to the QR, sorry, the whole thing. GF is parallel to the PQ. GF is parallel to the PQ, so parallel to this thing. So, and the QF and the QF. Okay, the FR is equals to 9, the QF ratio FR. QF ratio FR, I'm reading from here. QF ratio FR is equals to the P ratio Q. So that find the ratio of the areas of the triangle PHG to that of the triangle PQR in the terms of P and Q. This is a parallelogram, so whatever is this side, same side is here. And whatever is this side, same side is here. That's question number 8. So let me show you my solution. Triangle PHG and the ratio triangle PQR, the areas, the ratio is question. So the triangle PHG divided by the full triangle PQR, that will be HG divided by QR. HG divided by the QR. The HG is basically P and the QR is P plus Q whole square. So the triangle PHG, the area of the triangle PHG ratio, the area of the triangle PQR will be equals to P square ratio P plus Q whole square. So that is question number 8. So let's go to the next part. And the next part is question number 9. He says 2 solid cones are geometrically similar and the height of the one cone is 1.5 times that of the other. Given that the height of the smaller cone is 12 centimeter and its surface area is 124 centimeter square, find the height, the surface area of the larger cone. So there are 2 questions in the question number 9. So let me show you. So here you have two cones, a small cone whose height is 12 and whose area is 124 centimeter square. The big cone, its height is 1.5 h, and we want to also find out its area. So the height 1 by height 2 will be equals to the h divided by 1.5 h. H and h will be cancelled, so height number 1 is 12. So 12 divided by height 2 equals to 1 divided by 1.5. So cross multiply it. So height number 2 will be 1.5 multiplied 12, and that will be 18 centimeters. So the height of this big triangle is 18 centimeters. Now the height 1 by height 2 will be equals to the height, sorry, area 1 by area 2 will be equals to the height 1 by height 2 whole square. So 124 divided by the area 2 will be equals to 1 divided by 1.5 whole square. So the 124, that this 124 and this 1 and this 1.5 is given in the question. So the 124 divided by area 2 will be equals to, in your calculator, if you have entered 1 divide 1.5 equals to square, answer equals to, so you get 1 divided by 2.25. So cross multiply it, so area 2 will be equals to 124 multiplied 2.25, and that will be 279 centimeters square. So when you multiply 2.25 with the 124, you get 279 centimeter square. So that was the question number 9. Okay, so we are going to the next question. Okay, so the next question coming up on the screen is, in the figure, the triangle XYZ, the big triangle XYZ, is an enlargement of the triangle XMN. So this is the center of enlargement, and this figure has been enlarged from CM, it has gone to CY, from XN, it has gone to the XZ. Okay, so given that the XM is 6 centimeter and that the areas of the triangle XMN and the MYZN are 14 centimeters square and 22 centimeters square. So the area of this small triangle is already given, that is 14, and that trapezium and that quadrilateral's area, which looks like a trapezium, its area is 22 centimeters square respectively. So find the length of the MY. So very easily I can find the length of the MY. Let me show you. So the triangle XYZ will be equals to the big triangle. This big triangle XYZ will be equals to the area of the triangle XMN plus the trapezium MNZY. So it will be 14 plus 22, and that will be 36 centimeter square. So the triangle XMN divided by the triangle XYZ will be equals to the XM whole square divided by the XY whole square. So 14 divided by 36 is equals to 6 by XY whole square. So you will have 14 by 36 equals to 36 by XY whole square. So XY whole square will be equals to 36 multiplied by 36 divided by 14 equals to, and you will get 92.57. The MY will be equals to the XY minus the XM. MY, you can see here, MY is equals to the XY minus XM. So you will have 9.62 minus 6, and that will be equals to 3.2 centimeters. So this is how you do this question. So today, my dear students, we were working on the chapter number 12 from the book D3. The name of the book is New Syllabus Mathematics 7th edition, and my class is studying this chapter, so that's why we have done this chapter. So I have tried my best to explain to you that how, if the two figures are similar to each other, how their areas and the sides are related with each other. If you have two figures which are geometrically similar, so you can find the unknown areas, you can also find the unknown sides. So I have tried my best to explain you the whole concept. And my dear students, if you find it that this video has helped you to understand the concepts, So please do like my video. Okay, so share the link of this video onto your Facebook accounts, into your Instagram accounts, and onto your Twitter accounts. I want to specially thanks all the students who are watching these videos all around the world. Special thanks to my students in Pakistan, in Bangladesh, in India, in Sri Lanka, in Mauritius, in Brunei Darul Islam, in Kingdom of Saudi Arabia, in UAE, and and some students are also watching these videos from the Burma. So thank you very much, everybody, for supporting my channel and watching these videos. So keep watching my videos. I will try to make more videos on these two subjects, physics and mathematics of the Cambridge O levels. So thank you very much, everybody. Have a good day, and God bless you all.